name is Sagren Go. I'm the research group leader for the Advanced Casting Research Technologies group in the CSR manufacturing cluster. I was asked on short notice to participate. I've prepared about 10 slides or so. I had a slightly different heading to this, looking at energy efficiency challenges and opportunities for the casting industry. Because whenever there's a challenge, there's always an opportunity to actually improve and make the industry more sustainable. So please feel free to stop and use the session as a discussion session. So if you want to ask questions, feel free to interrupt me. Okay, the presentation, I'll cover the importance of casting, and that's looking at castings in our lives. And I use the slide as a foundry process, giving a eye-level view of all the different types of foundry processes that exist. And not in detail, just an overview, and then the flow with some indications of the energy consumption and potential saving areas, followed by a case study that we did many years ago, showing how we can use technology in actually improving the efficiency and saving money in a foundry. According to the American Foundry Society, almost 90% of all products that we use have cast components in them. This laptop has got a cast magnesium chassis. Your cell phones have aluminium or magnesium castings in them. So I think one of the things is, say, within 1 meter or within your reach, you will touch a casting in some form or the other. So castings form a vital, or the foundry industry is a vital industry for the reindustrialization of South Africa. Because no matter what we do, you are going to encounter casting in some form or the other. And I make the statement that virtually every metal product starts as a casting. And the reason being is, a lot of people look at a chair, like the metal that you have, legs of this chair. You look at it as an extrusion or a pipe that's bent and welded, and you use the tube. But all of this starts from casting a slab, rolling, or in case of aluminium, you're casting billets or slabs, etc., which is a critical part of the manufacturing step. Get that wrong, and you have problems down the line in manufacturing. So you have a cascading effect of the foundry industry on all products, most products. I think the only product that I can think of that's not cast at this stage is your tungsten filaments. That's produced by powder metallurgy because of the high melting temperature. So that's why I say, billets, slabs, and then the castings that we're more familiar with and we talk about as a foundry industry generally is what we call secondary castings. That's your component castings, like a little product examples at the bottom, components on the iron, even implants, or even for artwork. And you can see from the sectors that it impacts it. It's virtually every sector. Okay, I do have a pointer. Okay, so castings is used in virtually every manufacturing sector. So in terms of reindustrializing this country and growing the manufacturing sector, this industry sector is going to be vital. If we don't transform it or change it or grow it going forward, it's going to be very difficult to achieve the localization targets that are in the automotive industry master plan and all the master plans that have been developed so far. I bring this up because the foundry industry is not just sand, okay? It's not just the secondary casting. So I normally present this as, this is the entire foundry industry. We generally focus on this side and very much on the expendable molds and sand casting, because you'll find that sand casting is used largely in the large component manufacturing, and hence you have the biggest production by weight in sand casting. But all of these has a place to play. in the casting industry or the manufacturing. And then I mentioned the primary industry. We do a lot of work in this area as well. The CSIR has done as a little miniature billet casting facility to when we do alloy development, we can cast billets to check how they perform. An example of how we helped industry to improve the extrudability of aluminium was in a project in around 2012. We were asked to help with Speco with an issue that they were encountering on the extrudability of aluminium billets. And it was mainly with the internally cast billets. You see, with Speco as a foundry that produces billets, they were having very inconsistent extrusion rates. And if you slow down the extrusion rate, the extrusions become more expensive, and they were struggling to compete with China. And we did a full factory analysis, and the problem was in the foundry. Fixed the foundry problem, the extrusion process became consistent. And they saved 6 million rands per year just by improving the extrudability and being consistent, having a consistent casting process. So you can see that foundry is not just products. We've got to think about it holistically. So I'm not going to go through all the details over here, but just keep that in mind. The foundry industry encompasses all of this. So that is why I approach it in this fashion. Look at it holistically, not just as components. Now, this slide, I tried to create a more generic flow, not specific to sand, to permanent mold or die casting or investment casting, etc. This is a generic process flow for producing a casting. I've included in here product design, which we don't do much of, and I think that's sad because South Africa used to be quite innovative in producing unique South African products. We generally are casting or manufacturing to print, and that's something that we need to encourage going forward, is our young people becoming designers and inventors to make uniquely South African products that we can manufacture in this country, okay? Because even with the auto industry, we can localize as much as we want. If they decide you're too expensive, they will take it out of the country. If you look at what's happening to the Australian automotive industry, that's been decimated. Because Australia became too expensive, they've exported their assembly plants all over the world. Okay? So we've got to think about these things. For now, localization is the quick win, but we've got to think big. Think about the young people becoming inventors, product developers. And it's going to be quite important. The casting industry will be very important in that. And product design is quite critical. You cannot take any product and cast it. You cannot take a product that's machined and suddenly make a casting. Or you take a plastic injection product and make it into a casting. You've got to design for it. And that incorporates mold design. From that, you go into mold design. There's modeling and simulation now available that lets you get to a final design quickly. And it's design that's going to give you a quick or with less repetitive work to get to a final product. Now, I tried to incorporate in here some of the energy costs. Melting takes up about 30%. This is from a paper that I'll share in the next slide. And then you have melt treatment, where the energy consumption is a lot less. Depending on the type of metal you work, the melt treatment varies. I'm not very familiar with steel. I work more with aluminium. And we brought in some nice solutions. What we found in our research and working with the casting industry, this area here lacked. And we introduced little courses where we went in and trained people on melt treatment and developed devices to help them. And we've actually rolled out about 20 of these little products into the aluminium casting industry back then to help with the melt treatment. Holding takes up a lot of energy as well. That's just before casting. Then you have your casting process, which is not really an energy-intensive process, just pouring. cooling, then shakeout. One of the things is, can we use that energy from the cooling for something else? All of these processes are losing a lot of energy. Is there a possibility to use it elsewhere? And then finally, you have your finishing and inspection. And inspection, you can get up to 20% reject rate after you finish casting. Another critical part is you'll find that you can get up to 90% of your material just chopped away, which goes back as scrap for recycling. And you can get up to 25% machined off. So these areas here are big win areas. I'll show you from the case study at the end how much you can save if you improve on these things. Okay, so now where are the potential saving opportunities? Again, I said this is not exactly, this is along the thoughts that we have, and I found it in a paper by Konstantinos Solanitis. Sorry, very difficult to pronounce, but it captured it quite nicely. I summarized what was in the paper, just the main headings, and these are your direct areas where you can save, and these are the indirect areas. Your direct areas is like examples is like preheating your metal so that you can reduce the amount of oxides formed during the melting process, reduce the amount of hydrogen that's absorbed into aluminium melt, which has to be then degassed, which then extends the next process, the cleaning process. So I'm not going to go into detail. So these are some of the saving areas. And then the indirect savings is improving your material efficiency. And that's, I'll show you in the next slide what we mean by that. Use of modeling and simulation. Again, by the case study, I'll show you how we can use science. I know a lot of the foundries are very reluctant to adopt these new technologies, but that works. Internationally, it's a norm. In South Africa, we are still starting to adopt it. And we need the young generation to come in and bring in, accept these new technologies that are coming through. And that speaks to 4IR, and I haven't even spoken about 4IR in this. Okay, that's another, we can spend the whole day talking about it. And then there's plant management. One of the biggest costs in plant management is air compressor. Air compressor cost, people don't take that into consideration. And how do we reduce use of that? How can we optimize? And there's various factors in here. So there's a lot of detail that we can go into, but these are just high-level opportunities. And then looking at the raw metal flow, I like the way this was presented in this paper. They started off using raw materials. Say you start with 1 kg. You go into melting, you lose a few grams. Then you go into olding, you lose more due to oxidation of the metal, and you have to scrape off and you have to treat it to make sure you have clean metal. Then the next step is your casting process. For example, during refining, where you clean the metal and you removing oxides and making sure the metal is clean and the right state for casting and up to the specification you want. You lose more metal there. Then you have fettling. This is where the big jump comes in. That's your runners, etc. You drop from 0.91 kgs to 0.46 kgs. Then the next one is you machine to final shape. Inspection, that's where you get reject rate. I'll give another example of an intervention we did in around 2011. The sand foundry was reporting a reject rate of 1%, but that was 1% from the client. We did an assessment of that for that particular component that they regarded as problematic. They had a reject rate at the casting after fettling, or before fettling, after we shake out and things, of 68%. And I did a full analysis of the time wasted. Then they repaired, and after the repair, you get to 70%, or 30%, or about 50% reject rate. But they don't take into consideration the time spent, people welding up castings and doing weld repairs. So I did a full analysis of that. The company was not, they took the report, but they never came back and indicated whether they implemented any of our recommendations. But it was just for us to do a process analysis. So companies tend not to look at, after they cast, what is the quality of my product? They look at what the customer is sending back to them. But the amount of reject, the amount of energy wasted just in that, in melting the metal. Okay. I will not go on for other things I observed at the foundry. It's shocking what goes on sometimes. Okay. So you have this and you finally ship a component which is you're selling 0.27 kgs out of 1 kg. Okay, all of this scrap, everything goes back into melting. You say, right, I'm not really losing that metal, but you're losing energy because all of that has been solidified and you're going to melt it again to cast more to achieve your targets. Okay. Now, we normally use the term energy or yield and in terms of defining how much of metal or what's the actual weight of casting that leaves the door. So if I cast 1 kg, I'm actually selling out 270 grams. So my yield is about 27%. Okay. So that as a big, if you can improve your yield, you use less energy because you have to melt less. If you can reduce your scrap, you're melting less metal. Again, improving energy. And this table here is again from another article that I found. This research was done around 2003. And it was commissioned by the Department of Energy in America. You'll find that in America, the different departments actually commission lots of research projects, even down to fundamental levels. It's not left to the science departments of, in our case, science and innovation. So we need to open, the government needs to be open to that, where it's real theoretical or applied research. Now I'm just going to give you one of the case studies that we've done. This was done, when I do research, I don't like to do research for the sake of doing research. So this was a research project on die thermal management for high pressure die casting. That is the original design of the die with the runners, etc. The company was having lots of issues. I'm not going to explain it. We eventually, through modeling and simulation, we came to that die design. That was a result. This was what the company selected because they listened to an international expert, which was a total mistake because that was, they didn't take into consideration certain critical things, and eventually they lost all the benefits. If they went with our solution, they would have had a 20% improvement in yield. The owner of the company verbally said he saves 2 million rands a year in melting costs. Just melting costs, not anything else. That is gas. That's his gas bill for melting is. But he selected this option, which wasn't what we proposed, and he ended up having to go back to almost that, this taking runners all around it to actually make it work. Because you always look at what your product specification is before you do your die design. The reason why you fill in that area is a requirement, is to achieve the certain product quality that your client wants. And if, when you went this way, you lost the quality in that area. And that was the mistake. And this is the die design we came up with. And as I say, we could have saved him a lot. And there's a few other examples. I think I've mentioned it already. And yeah, so this is case studies. Now this is, as I say, there's a lot of opportunities for us to actually become more efficient and be profitable. Because this company said, they can now compete with China on price because of this. Same thing with the aluminium extrusion. They said now we can compete with China on price. So we need to somehow bring this technology to our industry. And I know it's difficult to change mindsets because there are a lot of people who've been in the industry for many years. But that is the challenge that we face. Okay, thank you. So. Is there any questions?
Can you please elaborate between the difference in efficiency improvement versus cost cutting in foundry environments?
Okay, they go hand in hand. Okay, if you improve efficiency, your cost per product will decrease, and it requires some investment, but you become more competitive in the long term. I hope that answered the question, or does... Yeah.
Sagren, can you please elaborate between the difference in efficiency improvements versus cost cutting in a foundry environment? Thanks, Andrew.
Yeah. Yeah. The gentleman at the back.
Okay, thank you so much. My name is Jay, and I'm a delegate from the Platinum Incubator in Rustenburg. So one of the things we're doing is jewelry, and we have to cast some of the jewelry that is being produced. So my question is, because I'm interested in alloying, so another thing that we've been doing is come up with different alloys to improve the kind of jewelry that is being produced at the company. So what informs the kind of alloy that you can produce? I believe it's relevant in terms of what you have presented, even though you're focusing more on having the alloy or metal ready and casting it. But I'm talking about before you can even cast or make those products, what informs the kind of alloy that you can produce? In other words, how do I know that if I was to mix nickel, zinc, and copper, it would be possible, especially when I have to melt each metal individually and put them together to produce an alloy? I hope that makes sense. Thank you.
No, very relevant. We've done work in that area as well. Lots of work in the past, distance past, in gold alloy development for the jewelry industry. And the important thing is, you need to know what your customer requirements are. What do people like? Say, I'm going to use your jewelry as the example. They like things to remain shiny, not tarnish. And you want a little bit of strength, but you want it to be also workable for you to, as a jeweler, to actually be able to work with it. So in the past, we've developed gold alloys for the jewelry industry. They actually were quite successful. I think it was done with an external client, and they actually were planning to sell it out. It's eventually been commercialized to some degree. If you want to understand how the alloys behave before you actually make it, there's modeling and simulation, like thermodynamic modeling and simulation that we can use, where we can create the alloys using a computer and check the stability before we actually start making the alloys. You can go even one step back, where you go to atomic level modeling using ab initio modeling, okay, where you put atoms together and to see whether if you put these two different metals together, do you create a stable alloy? And once we have an understanding, you can make then bulk, small volumes, and we can even cast. Interesting is CSR have helped artists in the past and jewelers to establish. In one case, we used to do castings for artists through our investment casting facility. I showed you some pictures. We've got some interesting examples at in the foundry at CSR, and even help artists to establish foundries so that they can do the work themselves. They don't have to come to us. But if you're starting up and you need assistance, we can help do that. Do the first castings. Okay.
Sagren for a wonderful presentation. I think one of my questions is that how do we now convince industry in terms of adopting the technology? As you have shown an example where you have proven, maybe beyond doubt, that with this kind of solution, there are benefits that they can get, but however, it's still a difficulty in terms of adopting the technology. In your opinion, how can we move to that point where the industry can adopt the technology? Because I think some of the problems that are there in the foundry, there are solutions which are there. It's just a challenge of adoption. Thanks.
Yeah. Okay, maybe it'll be a bit controversial. I believe we need a young generation of foundrymen with fresh thinking. It's something that I think we need to bring young people into the foundry industry. I don't think people understand that foundry is a science. It's not just pouring metal into a hole and getting a shape out. It is called multi-physics. It's a combination of lots of different scientific principles to get the casting right. What you see in the foundry is an outcome of many years of research and development in the background. And a lot of the people that work on the shop floor have been working there for many decades and are not being trained in the new technology. And we need to change a mindset. And young people need to understand it takes, the first step is getting a qualification at the university. But your education really starts in the foundry and actually working. And learning from your mistakes, learning from your successes. And that's one of the things we're trying to establish from within CSR. I think Indivivo mentioned the learning factory. One of the, what we call experience centers in the learning factory is modeling and simulation. So we've set up an experience center where students can come in. We've simulated a particular component that we want to cast. The students will have access to the simulation. It's very difficult to learn to use it immediately, but show what the simulation says, and we do actual castings and then correlate the two. So we need to start that education, and we need to start transforming that aspect of the foundry industry. It's difficult to train older people, because even in that example that I showed, we still continued with the implementation. And when I visited the foundry, they were not listening to what we had to say, the older people. They had disconnected things that we said needs to be there. They're saying, but we've done this for 30 years. Why should I do it now? This doesn't make sense. I said, but if it's something to think about. Okay. I'm not sure whether I answered it, but that's what I feel. We may be able to do it from small examples.
Okay, afternoon everyone. My name is Sowa Maleka. I'm actually a research student at the Vaal University of Technology, and my research is actually within foundry efficiencies and stuff. So I just wanted to make a comment in terms of foundries and stuff. So what I'm thinking is that how about in order to actually, make people look into a certain direction, because I've worked for a foundry for quite a number of years. So when something is working, you don't want to mess with that. That's basically the main thing about what I've noticed in terms of foundries, is that whatever that you are doing, it's working, and taking into consideration the methods that are used to get to the solution, is that it's a tedious process. It takes months to actually get something out of the foundry, and it can take other months for it to come back as a scrap in the process. You understand? So once you get something that works, and you have to think about it becoming a scrap by messing with a working process, it's something that I think many foundries will not necessarily just go into that easy. Understand? So wouldn't it be, because now we are in that situation whereby the country itself wants to actually improve the metal casting industry, if the CSIR can actually establish their own foundry, put the technologies there, because the only way for somebody to follow you is when it sees that it's working. You have to put your hand first in the hot water, then we will follow you after that. Something like that. I'm just making an example in terms of that. So now, what I'm saying is that if they can establish their foundry, you can take whatever product that is being made, there are so many products, and then make them use the technology as an example to show the industries in South Africa that, simulation, magma simulations, and all of this other simulations, CAD softwares and so forth, can actually bring a certain level of efficiency in terms of production. Because simply going into a person's house and saying, hey man, you can do it better with this and this and this, and then he knows that it's going to take some time, and if he fails, it's on his head. You understand what I'm saying? Okay. So, yeah, okay.
No, I'm glad you brought it up. I didn't bring it up. Okay. Basically, we have foundries. Okay, sorry, you must have taken. Oh, we're running out of time. Okay. Oh, there's a lot of questions online.
It's here. Oh, thank you. Gardner Deu from Ekurhuleni East Tibet College. We are running the Gauteng Foundry Training Center there. So I just want to follow up on what the previous speaker was saying. To say sometimes it's very difficult to just walk into an industry and try to implement change there. So maybe we can actually propose to say, if there is a possibility, we offer a playground for that.
Okay.
Whatever it is that needs to be experimented on, then you can actually use our training center. We are training artisans. We have pattern makers, molders, and melters. So I think it's a very, very perfect ground for such trials to be implemented. And these new technologies, when they are introduced even through us, when we place these apprentices at the companies, I'm sure they can also make more meaningful contribution in terms of efficiency of the processes. Thank you.
Okay, just quickly, just to run, a center like that has been proposed, and I'm glad that we have support. We do have facilities to train at CSIR, actual casting, industrial scale facilities. This is not common. This is not unusual for South Africa. This is now becoming a norm internationally. Brunel Center for Advanced Solidification Technologies, BCAST, has set up what they call an industry playground. They received a few £100 million to set up. It's brand new facilities, 1,500 square meter facility with brand new equipment. They're saying they understand industry cannot play in the factory. So this facility is created for industry to play outside the factory. And we have put in a proposal to that effect. And if it's approved, we'll have the first phase of it this year. Okay, so yeah, we're thinking exactly the same thoughts, and I'm glad that we share the same vision and what we would like to offer to the industry. We understand industry is under pressure and they need to produce. Yeah.
Must also, as an industry, stop making excuses. I mean, when you look at the development of simulation, it's actually disheartening to sit here and we still sense there's still a bit of resistance because people are wanting to try to use excuses. If you look at in the past 10 years, how simulation in terms of custom manufacturing has advanced. Yes, initially it was expensive, but there are so many options. And even us as industry partners, there's companies which already have those facilities which can be utilized if we strengthen our relationship. So you don't need an independent center to be a playground. You just need to liaise with your counterparts where you're struggling, and we can assist one another in ensuring that we're becoming more efficient.
We're too small an industry to be competing and fighting each other.
Exactly. So, and I think that's where we need to move on. Because as my colleague has said here, some of the things you presented, like your yield in relation to your simulation, there's no way in this day and age you can actually know your yield is correct if you haven't simulated that model. Because you're guessing. You can come with theoretical calculation, you're still guessing. But also the simulation will give you the advantage because there's certain incidences where you'll simulate, but you'll still get the defect. But it gives you the advantage to liaise with your customer beforehand and say, these are the issues before we even move to production. How are we going to overcome that? At times, they will even sacrifice the yield. You'll get a poor yield, but they will pay for it. Yep. So the issue of saving cost and melting becomes irrelevant because you now have something in black and white that you can use to justify where the challenges are. Yeah. So I think as an industry, we must just work together. There's already enough resources to actually benefit everyone else. Thank you.
Okay. Thank you. I think one of the things we are trying to steer in the new direction, Sagren, I wanted to say 90% of people here are industry people and they look young. I look young, okay? I'm 20 years, we are all 20. I don't think there's older people here, so... so the challenge about saying that we understand the issue, but we are playing in an open field in our colleagues. If you are not competitive through your processes and efficiencies and manhandling and manpower, you're out of the game.
In 2005, I was hosting a group of, we worked with Jetro, and they arranged a tour of Japanese foundries. And I so happened was in Japan, so I ended up hosting the group. And we visited Toyota global Toyota head office in Toyota City, and we met the global purchasing manager. And you know what he says? Toyota is only interested in their profits. So they expect any foundry or any supplier to continuously improve. Even though you may get the contract, every year you've got to continue to improve. And that's what, and if you, from all the foundries I visited in Japan, that's what they do. They have research and development in the foundry. And I was most impressed with the one foundry casting Suzuki engines, where they started off with 30% reject. When we visited them, they were down to 10% and the target was 5%. And they do the research internally inside the foundry while they're doing production. Okay, so it's something to think about. It's, yeah. Okay, thank you.
Thank you, Dr. Gavenda.